Hi, hello, and welcome to our YouTube channel AxelBuzz Software Testing, where you will learn in easy, simple way. So, our today's topic is smart contract in the blockchain, and we are going to discuss test scenarios of this, which type of testing to be done on this blockchain. This video is little bit lengthy, so we have divided this video into two parts. In first part we will be discussing few testing techniques, and in second part we are going to discuss remaining one. So let's get started.
First, take a look what is smart contract. Smart contracts are the self-executing agreements with the terms of the contract directly written into the code. They are computer programs that are automatically executes and enforce the terms and conditions of the contract within the need for intermediate. Smart contracts operates on the blockchain platform, most commonly on Ethereum, and although they can be implemented on the other blockchain networks as well. These types of testing ideally should be done on the smart contract while testing. So these are basic types and we will see in detail all the scenarios of these types. Test scenarios of the smart contracts. First of all, functional testings of the smart contract. These things you should consider while doing functional testing. Contract deployment. Verify that the smart contract can be successfully deployed on the blockchain. Then confirm that the contract address is generated and accessible. Contract initialization. Validate that the initial state of the contract is set correctly and check that the constructor parameters are initialized as expected. Contract functionality. Test each public function of the smart contract individually. Then verify that the function execute the intended action and produce the expected results. Test both the positive and negative scenarios, including boundary cases and edge conditions. Data storage and retrieval. Ensure that the data is stored accurately in the contract storage variable. Validate that the data can be retrieved correctly from the contract. And test the scenarios where the data is updated or deleted to confirm that contract's behavior. Event emission. Confirm that the contract emits events correctly during the specific action or state changes. Validate that the emitted event data is accurate and matches with the expected values. Access control. Test different access levels and permissions defined in the contract. Verify that only authorized user or roles can perform restricted actions. And validate that the unauthorized users are denied access to protected functions or data. Contract interaction. Test the scenarios where the smart contracts interact with the other contracts or external systems. Then validate that the data or funds are transferred correctly between the contracts. Ensure that the contract handles external callbacks or function invocations appropriately. Contract upgradability. If the contract is designed to be upgradable, test the upgrade process. Verify that the new version of contract can be deployed or interact seamlessly with the existing data or contracts. Time dependent functions. If the contract has time dependent functions or time based conditions, test their behavior. Verify that the contract reacts correctly to the different timestamps and times. Error handling. Test the scenarios where the contract encounters the error or exceptions. Validate that the appropriate error messages or exceptions are raised. Confirm that the contract gracefully handles unexpected or unexpected behaviors. These are some boundary testing scenarios of the smart contract. Maximum and minimum values. Test the contract's behavior when using maximum and minimum values allowed for different data types like integer, timestamps, and monetary values. Then verify that the contract handles these extreme values correctly without encountering overflow or underflow issues. Array bounds. Test the contract's behavior when assessing element at the boundaries of the arrays or dynamic data structures. Verify that the contract correctly handles the edge cases such as assessing the first and last element or exceeding the array length, etc. Loop iterations. Test the contract's behavior when executing loops with the maximum and minimum iterations. Verify that the contract does not encounter performance issues or exceed gas limits during the iterations. String length. Test the contract's behavior when handling strings of maximum and minimum values allowed. Verify that the contracts can handle long strings without encountering gas limits issues or truncating the data. Transaction limits. Test the contract's behavior when reaching the maximum allowed number of transactions within a block. Verify that the contract can handle the transaction congestion without encountering issues such as out of gas error or transaction failures, etc. Gas limits. Test the contract's behavior when executing functions that require maximum gas limits. Verify that the contract can handle gas intensive operations without running out of gas or encountering execution failures. Overflow and underflow. Test the scenarios where the contract performs mathematical calculations like addition, subtraction, multiplication, etc. that may result in overflow or underflow. Verify that the contract handles these scenarios correctly by preventing the overflow or underflow issues and providing accurate results. Input validations. Test the contract's behavior when the receiving input values at their minimum and maximum allowed ranges. Verify that the contracts correctly validates and handles these inputs values without accepting invalid or out of range inputs. Time based conditions. Test the contract's behavior when the dealing with the time based conditions such as time based locks and expirations. Verify that the contract triggers are expected actions when the reaching the boundary conditions defined by the time based logic. Resource limitations. If the contract involves resource usage, such as storage or memory, then test its behavior when reaching the maximum allowed resource limits. Verify that the contract can handle resource limitations without encountering these issues, such as out of gas errors or exceeding storage limits. These test scenarios aims to validate the contract's behavior under extreme boundary conditions. The specific scenarios and values to be tested may vary based on the contract's specific requirements and data types used. Let's understand the exception handling test scenarios of smart contract. First one, invalid function call. Test calling a function that does not exist in the contract. Verify that the contract throws an appropriate exception or revert the transaction. Unauthorized access. Test accessing function or data that restricted to specific roles or addresses. Verify that the contract throws an exception or revert the transaction for unauthorized access attempts. Insufficient funds. Test scenarios where a user does not have enough funds or balance to perform a specific action. Verify that the contract throws an exception or revert the transaction when there are insufficient funds. Out of gas errors. There's scenarios where a function execution consumes more gas than a block's gas limit allows. Verify that the contract throws an out of gas exception, ensuring that the transaction fails gracefully. Resource limit exceeded. Test the scenarios where the contract exceeds the resource limit, such as storage or memory. Verify that the contract throws an exception or revert the transaction when the limits are exceeded. Contract state validation. Test the scenarios where the contract expects to certain state or condition to be met before executing a function. Verify that the contract throws an exception or revert the transaction if the required state or condition is not met. Invalid data or format. Test the scenarios where the contract receives invalid or unexpected data or data in the incorrect format. Verify that the contract should throw an exception or revert the transaction when encountering such invalid data. External contract error. Test the scenarios where the contract interacts with the external contracts and encounter the errors or exceptions from the interaction. Verify that the contract handles external contract errors gracefully or throws an appropriate exception or revert the transaction. Recursive function call. As a scenario where a recursive function call exceeds a maximum stack depth allowed by the blockchain. Verify that this contract throws a stack overflow exception or revert the transaction when maximum stack depth is reached. Exception propagation. As a scenario where an exception occurs a function and verify that it propagates correctly to the higher level functions or transactions. Verify that the contract throws an exception or revert this transaction, ensuring the exceptions are properly handled and propagated. These test scenarios are useful to validate how smart contract handles and responds to various exceptional situations. The specific scenarios will depend on the contract's functionality, requirements, and potential exceptions that may occur during the execution. Let's understand the input validation testing of a smart contract. Valid input. Test the contract with the valid input values within the expected range. Verify that the contract accepts and processes the valid input correctly. Invalid input values. Test the contract with the input values that are outside the allowed range or formats. Verify that the contract rejects these invalid inputs and provide appropriate error message or exceptions. Empty or null values. Test the contract with the empty or null values for mandatory input fields. Verify that contracts correctly detects and handles these missing values, providing appropriate error message or exceptions. Boundary values. Test the contract with the input values at the boundaries of the allowed ranges. Verify that the contract handles these edge cases correctly, including upper and lower bounds, to ensure proper validations. Data type validation. Test the contract with the input values of incorrect data types or specific fields. Verify that the contract rejects the incompatible data types and provide clear error message or exceptions. Length validation. Test the contracts with the input values that exceeds or below the allowed length limits or for specific fields. Verify that the contract correctly validates and handles these length restrictions, providing appropriate error message or exceptions. Format validation. Test the contract with input values that need to adhere to separate formats, for example, email addresses, phone numbers, etc. Verify that these contracts perform format validation and reject the inputs that do not match with the required format. Unique values. Test the contract with the input value that should be unique, like unique identifiers or account names, etc. You verify that the contract detects the and handles these situations where the duplicates and non-unique values are provided. Enumerated values. Test the contract with the input values that should match a predefined set of options or enumerated values. Verify that the contracts correctly validates these input against the allowed options and rejected values that are not within the specified list. Cross-field validation. Test this contract with the input values that required validation across the multiple fields or dependencies and verify that the contract performs cross-field validation checks and rejects inputs that do not satisfy this interdependence. These test scenarios focuses on validating the input values provided to the smart contract, ensuring that the contract correctly validates, accepts and rejects these inputs based on the defined rules and constraints. The specific scenarios and rules to be tested with the dependent on the contract's requirement and the fields involved in the input validation process. There are some more testing types remaining with the scenarios. This video is becoming little lengthy, so we are ending this video here. This is part 1 video and part 2 will be posted on next Friday. If you like this video, please hit the like button and subscribe to our channel. We post videos on every Tuesday and Friday, so stay tuned and happy testing. Bye bye.